7-9. Completing the square review. Sometimes an equation of a circle is not written in standard form, so we must use another Algebra 1 technique to rewrite the formula into our standard form. This complicated Algebra 1 technique is called completing the square. This lesson will be all about a review of this technique. Here are my steps for completing the square. Step 1. We're going to move the quadratic and linear term to one side and isolate any constants on the other side. So essentially, we're going to move our x squared and x terms to one side, and we're going to move our constants, any numbers, to the other. Once we've separated those terms, we're going to move on to our step 2. If the coefficient of the quadratic term, so if our number in front of the quadratic, our x squared, is not 1, we'll divide it out. Most of our problems will have a coefficient of 1 and we'll be able to skip this step, but if the coefficient is not 1, then we will have to go ahead and divide it out so that it is 1. The next step is the completing of the square. We're going to add half of the b term over 2 squared. In other words, half of the linear coefficient squared to both sides. This is actually creating a perfect square binomial. After you've completed the square, you'll move on to step 4, factoring the perfect square on the left-hand side. Once you've done this, essentially what you're doing is you're eliminating the two x values in the problem and getting only one binomial with one variable within the problem. And you can solve for it in step 5 using your square roots. So let's take a look at two examples of completing the square. Example 1. We have x squared plus 10x plus 14 equals -7. The very first step is to isolate our constants on one side and our linear and quadratic terms on the other. So that means that I want to keep my x squared and 10x on the left. And I want to move anything without an x term to the right-hand side. So I want to move the 14 to the other side. To do this, obviously, I'm going to subtract the 14 from both sides. This will give us x squared plus 10x. I'm going to purposely leave a space in between the quadratic and linear term and the equal sign. Then on the right-hand side, I have -7 minus 14 to give me -21. The next step is to divide through by the leading coefficient of the quadratic if it's not 1. If we look at our quadratic term, it is 1, and there's nothing to do for step 2. So step 2 we can skip. And we move on to 3, completing the square. We're trying to create a perfect square binomial here. So we need to add something to both sides. We will always add our b over 2 quantity squared to both sides. For this problem, our b term is going to be 10. It's always the linear coefficient. So essentially we're going to add 10 divided by 2 squared. Or 10 divided by 2 is 5. 5 squared is 25. So we're going to add 25 to both sides. The reason why we do this is because on the left-hand side, this trinomial is a perfect square trinomial that you studied about in Algebra 1. It turns out to be a binomial, 2 terms, quantity squared. Next step is to factor this trinomial into its perfect square binomial. This perfect square binomial will always be x plus or minus b over 2. So in other words, it will be half of our b term. So half of our 10 will be 5. So we'll leave it as +5. Okay? So I'm going to write 10 over 2 because for this problem it's 10 over 2. And this will be equal to our simplified coefficients on the right. So -21 plus 25 will be 4. Once you've once you've factored the trinomial over on the left side, you're ready to solve. So let's go ahead and solve this thing. So I'm going to just rewrite it over here, x plus 5 quantity squared equals 4. So to solve for my x, I want to peel off my layers, so I have to get rid of the square. The opposite of a square is a square root. So I'm going to take a square root of both sides. When I take the square root of the square, it just leaves me with the binomial x plus 5. And when I take the square root of 4, that's going to give me 2. But you have to be very careful. When you're solving an equation and you're taking a square root, you have to consider both the positive and the negative root. So our answer will actually be plus or minus the square root of 4, or plus or minus 2. So what we actually have is two solutions, or two problems now. We have x plus 5 equals positive 2, and we have x plus 5 equals negative 2. So we'll solve both equations separately. To solve the first one, we're going to subtract 5 from both sides, and we get a solution, negative 3. This is our first solution. For our second equation, x plus 5 equals negative 2, we will also subtract 5 from both sides, leaving us with x equals negative 7. And this is our second solution for this quadratic. So here we have our two solutions, negative 3 and negative 7. Okay, so let's take a look at the second example. 7x squared minus 14x minus 56 equals 0. First step, move any constants over to the other side. In this case, I have a negative 56. So I'm going to go ahead and move it to the right-hand side to isolate it by adding 56. Again, I'm going to leave a big blank here for me to complete the square soon. 0 plus 56 will be 56. Okay, step 2 is to check to see that you have a coefficient of 1. Unfortunately, we do not. So step 2 tells us if we don't have a coefficient of 1, we need to divide that number out. So I'm going to take that 7 out by dividing it, and I'm dividing it to everything. So 7 divided by 7 will get me just 1, the coefficient that I desire, or you can think of it just as x squared. Negative 14 divided by 7 will give me negative 2x. Again, big space here to complete the square. And 56 divided by 7 will be 8. Okay, so now that we have a coefficient of 1, we move on to step 3, completing the square. We're going to add that b over 2 quantity squared in that blank. So b over 2 squared. For our problem, our b term is negative 2. So I'm going to do negative 2 over 2 squared. Negative 2 divided by 2 gives me negative 1. Negative 1 quantity squared is going to be positive 1. The b over 2 squared should always be a positive number. If you're ever trying to add a negative when you're completing the square, you're not doing it right. Because when you square a number, whether it's positive or negative, it will always make a positive number. Okay, so our completing the square would be adding 1 on both sides. This will make the left side a perfect square trinomial. So it will turn into a perfect square binomial. So it's going to be x plus or minus something, and it's always going to be half of the b term. In this case, the b term is negative 2, so half of it will be negative. So in this factoring step, we could have a negative number, and we do in fact, x minus 1. And this will be equal to 8 plus 1, 9. Once you've factored, you're ready to start to solve. So x minus 1 quantity squared equals 9. We begin to solve by getting rid of the square, taking a square root. On the left-hand side, the square root and the square cancel, leaving you with just x minus 1. On the right-hand side, we have both the positive and negative square root of 9, or 3. And we have two right-hand side values, so I'm going to just split this into two equations. X minus 1 equals 3, and x minus 1 equals negative 3. Solving each of them separately. Our first equation, add 1 to both sides, giving us an answer of x equals 4. Our second equation, we're going to add 1 to both sides, giving us a final answer of negative 2. And those are our two answers for this particular problem.